Hi everyone, you're welcome to today's lesson on MATLAB for Engineers brought to you by the Guide Academy. My name is Martin and I'm your instructor for today's lesson on conditional logic. Now, so far we have worked with programs that are executed in sequence, right? And basically every single line is executed in that order until the program completes its task. However, sometimes we might need a program to do more than just that. We need to build intelligent programs now that we are dealing with scripts. We need programs that can take decisions, that can account for scenarios, multiple scenarios, and so on. And once we step into that, we need to be able to program logic into these programs. So for instance, you could have a simple ticket printer that asks for name, date of birth, and other details of a customer to print a ticket for them. Now, such program, the algorithm will basically have an input section that prompts the user to enter these details, and then a processor that just processes that and then prints appropriately, or prompts a printer to print out a ticket. Now, that is just the simplest form of that program, but if you think about a modern day program that would do that, this program is very limited. A real program now would be expected first to be able to correct errors, right? If someone entered the ID in the date of birth section or entered their name in the ID section, the program should be able to pick that up and prompt them that the entry was wrong, or not even allow them to enter that. It may also have an age classifier. There may be an age rating for the program, and you may want to impose as a condition that prevents underage customers from accessing, being able to buy tickets and accessing the show. So this change, if you want to make changes like that, you need the program to have decision-making abilities. So in this case, it will verify the age of customers and then be able to decide based on the age whether it's right to print a ticket or not. Now, in more technical fields, science and engineering, we use equations a lot for estimating several parameters, and very commonly you don't have one fits all relations. So especially when it comes to empirical relations in engineering, you usually have an entire region and multiple correlations being better fits for different portions of that region. So assuming you are calculating something that depends on the diameter of a particle. Now, it may be that when the particle size is very small, maybe 5 millimeters and below, some relations underestimate whatever is being calculated. It could be the terminal velocity, right? And yes, you could have an instance where if particle size is very small, one relation works better than another, and the other works better when the particle size is above a certain range. Sometimes you can have 3 or 4 of these relations stacked to cover the entire region for that phenomena. So in that case, you would need the program to be able to decide based on a user-entered particle size which relation is appropriate for estimating the terminal velocity of that particle. And all of these are decisions that a program needs to make. And we need conditional logic. We need tools that allow us to program logic into our code. So conditional logic is simply the mechanism by which a program makes decisions as to which path should be executed or ignored. So rather than simply executing every line of code from start to finish the way we are used to, programs with conditional logic will evaluate a situation and choose what to do based on the prior results. So if you think of that, you can envision it as a point where if a code reaches a condition or a point where it's supposed to make a decision, it looks at the current value or the latest computation and then makes a decision based on that value and the condition there, and that determines the next line of code or the branch that is taken in the code. So it's common to also have conditional logic being referred to as selection statements. And in MATLAB, This conditional logic, not flow control, it should be conditional logic. It's handled by the if and switch statements. So let's get right into the if statement. Now the if statement is fundamental conditional construct. It's a general construct for conditional statements. And the way it works is the if statement precedes a logical expression or a relational expression. We recall from our first lesson that logical expressions use logical operators to evaluate or compare situations and evaluate logical. So 5 is less than 3. Is that true or false? Basically, true or false scenarios. So if the condition is true or if that condition is met, then the associated block is executed. If the condition is not met, then that action or block of code is skipped. So if you want something to only happen under certain condition, that is what the if statement helps you do. So the general form is the if statement, and then whatever the condition is, maybe if x is less than 5, then action. Whatever is done if x is less than 5, and then end. So that's the simplest form. If x is less than 5, do this, and then end. Right, so that is the simplest form. There are more complex forms. We'll see that as we go on. Now, the if and end statements enclosing the code is the framework for activating the conditional behavior in MATLAB. So this is just how to initiate and terminate the if conditional statement. So the condition is that relational term that evaluates to true or false. And then the action is the code that describes what should happen if the condition was met. Right? If this yields true, the action that should be carried out. That is what this part is. So here we have an example where the program determines whether a certain variable called num is negative, and then it sets it to 0. Now a variable num with a value of 4. So this code here, if we look at it, let's demonstrate this in MATLAB. So I'm going to create a script. Now we create a variable called num, and then we assign a value of 4. So now if we could have some definition here. So you start by just typing if num is less than 0. So this is a relational statement, right? If num is less than 0. So it's if num is not, this will yield true or false, right? If you just type this, it would have given true or false based on what the actual value of num is. So this, let's keep that in mind. Now, if num is 0, okay, what should be done? So if num is 0 is less than 0, that means it's a negative number. Let's square num. So let's evaluate y as num squared. And so if y is less than 0, we want to avoid negative numbers. So let's say if num is less than 0, we square num and assign it to y. Now after y is computed, we just ask MATLAB to display y. So display the value of y for us. And then we need an end statement. So MATLAB will really align that once you type it. And here we have our loop, condition. So we have to save the file. So but if you decide to write it, MATLAB will still prompt you to save it. So let's call it yes. So now let's run that. So what happens? We obtain no output. Now if we look at the code, we see why this is happening. Num equals 4. Now the condition says if num is less than 0, execute whatever it's here, square num and then display y, end. Now because num is not less than 0, nothing happens, right? It's just the same as if you had just typed num equals 4 and didn't do anything else. right? Now, immediately we change this to a negative number, -4, and then we run, we get an output 16, right? So this block of code only evaluates if this condition is met. Right? Now, if we wanted it to do something else other than that, we could have brought in another conditional statement to cover the other case scenario, right? So if we do not want that to happen, if we don't want it to do nothing, we could tell it what to do when the condition fails, and that brings us to else. So the statement for doing that, for programming additional conditions, or for programming the alternate condition, right? If the if and end simply checks whether the first condition is met, and then does that, it does what it's supposed to do when that condition is met. But if that condition is not met, it doesn't do anything. So it only runs if the condition is met. However, if you want it to also do something, even when the condition is not met, you bring in else. So else accounts for when the condition is false or this evaluates false. Right? And then you tell it what to do when the condition is not met. So simply display number is positive, you may proceed. Right? So once you do that, if you run this code and it's positive, right, you simply get that as your output. Okay. So what it does is first checks what is num. Num is not less than 0, so it skips this and goes to the else. Then it displays this. Right, now if num is less than 0, if num is a negative number, if we run this, we get 16. If we make this -2, we should get -4. You get 4, sorry. Square squared -2 gives you 4. So that is simply how if and else work together. So this program is now intelligent. It will take in a number and perform a certain action based on the value of the number or the sign of the number. So to make this even more intelligent, what we could do is to use an input statement. So let's place an input statement here. Input, enter value for, let's specify a numerical value. So let the user know, and then they should do it. Now let's just put clear and CLCOE. Now let's run this. So we are asked to enter a numerical value of choice. Now let's enter -8 and see what happens. So we get a squared. However, if we run this and we ask for, we put in 10, say if number is positive, we don't need any squaring, so proceed. So this is how to build an interactive program that is able to take a decision. Now this is a very simple one. Let's look at more, adding more complexity. So we've established this, how if works. We've also looked at else. So that the syntax is simple. If the first condition, now the code will run if the condition is true. Other than that, the code will run, if you have else, the code will run if the condition above is false. So that is how the if else statements are able to account for almost every scenario. Right? You can use them to impose almost any kind of condition on your code. Now, what if you want to impose more than one condition? Right? If you don't just have a condition and its alternate, you have maybe 3 or 4 conditions. Maybe there's something to be done when the number is less than 0. You want something to be done when the number is 0, and then when the number is greater than 0. So in that case, you have more than 2 scenarios, and if and else alone is not enough. So that brings us to else if. Now, else if lets you change additional conditions. So that allows you to add additional condition to your program, and that is what brings the if else if and else full circle. That's what really makes it cover every case. So in this case, remember we've not accounted for 0. So as things stand, if you run this code and then we enter 0, it will be treated as a positive number, but 0 really is not positive, right? So if we want to correct that, what we can do is right after the first case where it accounts for negative, we can go else if. So else if num is 0. Remember, for equality, you use the double equal sign. Display the value as no magnitude. Let's say our view shell, your value has no magnitude, so we can display that. And then now when we run this, sorry, hold on, expected oh okay, sorry, this has to be on the same line. Let me just move it up. This has to be on the same line. That's a silly mistake. So now if we enter 0, we get that accounted for. So we have something for a negative, neutral, and a positive value. Right. So else if allows you can add more. You can even add another condition, maybe if else if num is less than. You just have to be careful so that you do not mix up the range. So assuming I go if num is less than 50, it should do something. I need to remember. For now, this is fine. This will work, but it will clash with this at the point because negative numbers are also less than 50. So it's important to note that these two will overlap. All right, and in that case, the first one might execute and this will never work. And the second one, but let's try that and see what happens. We should expect only the first one to be paid, and this will only work if the number is greater than 0. Right, so let's just test that. Let's say low value. So let's see if it's less than 50, low value, and let's run this. So let's put 10. We get low value. Now we first it checks if the number is less than 0. It's not less than 0, so it bypasses this. It goes to the next statement. Is it equal to 0? It's not equal to 0, so it bypasses this as well. Then it comes here. Is it less than 50? It is less than 50, so we get low value, and this is skipped, right? But when we enter a negative number, say minus 10, we get 100. And what happens here is we need to note that both of these conditions apply, right? This is true, and this is also true because minus 10 is less than 50, and it's also less than 0. But what's happening here is the first one, when it gets here, this one is executed. So if num is less than 0, num is actually less than 0, so it gets squared and then displayed, and then everything else is skipped. So you need to be careful when you are chaining these. So if we actually wanted to create a range, maybe we wanted between 50 and 0, then what we have to do is use relational or logical statement. So which logical tool is going to be most appropriate here? We have or, if we recall what or does, and then not. And we know that for or, you need one of them to be true. So either this is true or this is true, and then the expression is true. Then and needs both of them to be true. So both this is true and that is true. So in this case, if we try and num is greater than 0, then what happens is we first check is num less than 50. Yes, it is. Is it also greater than 0? Yes, it is. So both of these need to. be evaluated before this can be true. And that is what's appropriate here. If we put or, and what will happen is once the first one is true, it's not even going to bother itself to evaluate the next one. The whole thing evaluates the true, and that will be wrong key. So we need and now when we run this, we should still get the same behavior, no value, because it failed everything until it got to this line. However, to really demonstrate this, let's make small adjustment. Let's bring this part of the code here. So I'm going to place this at elseif over here. And then I'm going to move this to the first line. So now the first thing that is run is this. So if I omit this, let me try to comment this out here. Now we just have if num is less than 50, display low value. So when you run this, and even if we put in a negative number, -10, we get low value. And that is because even though this also applies, we've told it that if num is a negative number, square it and display y. But we've also said if num is less than 50, low value. And because this is first, this comes first, it takes precedence, right? And that is what is followed. But once we insert this, we have this condition. When you run and then we have -10, it gets squared. And that is because this range is now, so all you're saying here is if num is between 0 and 50. And that is what we said here. And that is not true. -10 is not there. It comes here, is it 0? It's not. Then it comes here, okay, it's less than 0. And then that gets run or displayed. So that is simply how the if statement works. So for logical operators, we've studied that, but let's just do a short revision. And then let us combine or negate conditions in when we're dealing with conditional statements. So over here, we did mention that they are vital when it comes to creating intelligent program, and this is why. So we remember the and for scalars, it stops evaluating if the first operand is false. So it needs both statements to be true before it runs. So immediately the first one is false, there's no way both of them can be true. So it just stops there. Or stops evaluating if the first one is true. It needs one of them to be true. So either the first or the second is true, it's going to run. So once the first is true, it doesn't need to check both to know that at least one of them is true. Then there's not, that just negates a condition. And then there are the element-wise version. So when you have double, it means you're working with a scalar. And then when you have vectors and matrices, you use the single version so that you have element-wise operation. So that is simply for conditionals and relationals. Now there's an example here. If you can clearly see, there's a temperature variable that has been initiated. There's humidity, and then you check if temperature is 37 and humidity is greater than 80. So temperature is greater than 37, humidity greater than 80. You should display something, and then end. Now this is very simple. So if it doesn't obey this, it's simply going to do nothing. So we've seen how to account for other case scenarios, and also how to change additional conditions. Maybe if there's another range and we want to do something else, if the temperature and humidity fall within that range, then we do that. We can also use inputs to ensure that these are user entered values. Now let's move on to switch statements. So switch statements are essentially alternates. There's an alternative to if, but it's a special case alternative. It does not cover all the breadth that if can. So someone can just decide to keep using if, but they are also useful to know or have. So when you have one single variable, and so for instance, if we look back at the previous example where we had num, working with num, so let's go to MATLAB. All right. Now, if for things like this, where you have a range, you cannot really use switch. However, assuming we had specific values, so we had specific values that we wanted to check for. So things would only happen, or something only happen if num is equal to 0 or equal to 10 or equal to 45 or maybe 50. So maybe let's do that. Let's create another script. Let's say num equals input enter the numerical value. So let's just say we have this, and then we want to use a switch statement. Now, let's say in this particular case, num we only want to check if num is of 3 values, right? Those values are 0, 50, and then 500. So what happens then is because we just want to check for these 3, we do not have to go through the hassle of writing if statement, if this all that, although an if statement can do it. So if we wanted that, we can just go ahead. If num is 0, do this, right? Display, so let's say neutral, and then we have else if no is a second number of 50. So display I don't know, say 50, and then else if num, and our last number was 500. Display. So maybe let's do this. Tens, hundreds. Right, but we are only checking for these numbers. And then we need else we do not really need, but we don't want the program to do nothing if any of these are not followed. So else number not available, and then end. So they should do what we want. Right, we go ahead and save that. Let's call it if char if2. So now let's run this, and then we enter 0, neutral, can run and enter 50, tens, and then 500, 100. So it's doing everything it should. If we enter anything else, 30, number not available. So that, okay, I think I should have put display here so that this is not formatted as a string in that sense. We just want the text. So 30, yeah. So that's fine. Now we can do this with a switch statement, and it's a bit simpler. So that is an alternative to doing the same thing. So we've seen that the if can actually handle it, but now let's look at what a switch does. So once you have a single variable, in this case we had num, and it can take several known discrete values, then the switch is more cleaner and a bit easier. Now MATLAB switches the switch statement will compare the switch expression against a value using the equality, just as we did with the if. And once it finds a match, it just executes that block and then goes out. Now there is otherwise that behaves like else. So let's look at the general syntax. So there's switch, the expression, and then case 1, case 2, case 3, case 4, otherwise, and then end. So if we are to apply that to our most recent code, I know we named it if, but let's switch. So I'll get rid of this now. We have switch And then what we need to do is we switch num. So we need to indicate the variable we are switching. Now, all we have to do now after switching num is go case 0, display neutral. Case 50, display tens, and then case 500, display 100. Then instead of else here, we have otherwise, and then end. So that is all, right? And if you run this code, we have 0, neutral, 50, tens, and then 500, 400, right? So it does the same thing. And the way it works is after num is given, num is switched. So it just goes through the code. If num, which has been switched, equals any of these values, it executes that, then it goes out. So where we entered 500, num is not 0 in this case, it's not 50. So it skips all of these. Once it gets here and num is 500, it runs it. And if num is neither of these values, assuming we put 60, it just runs otherwise. So just as else did for the if statement. So that's really how switch works. The switch statements can work for you. So there's an example here we should try out involving building a program that reports the thermal conductivity of a material specified by the user. So using if is demonstrated here. We'll not go through that, or maybe we should. Okay, let's try that out. Okay, I have it written here, so you can try that. So as usual, you have client CLC, then material. So we want to get the material. So we have material equals input, and this line of code just tries to get the material. Now, if the material is steel, so this is a string, and as such, we have the string indicator over here whilst creating the input. So if I were to do this, so we first try to get material. We need to know the material the user is specifying to get the thermal conductivity for that user. Enter material name in lowercase. MATLAB is case sensitive, so it's a good idea to let them know that. Now, if you are going with an if statement, you could just do if material, which is now a variable, is now this is a string, so steel is a string. If the string entered this, now we have our condition. So what should we do? If the material is steel, display the thermal conductivity of material. Oh, let's have steel. Yes. 40 watts per meters Kelvin. So this could be what is displayed if that condition is met. And then we could add else if what should be done. Else if material, so variable, is something else. In this case, copper. The display should be this. The thermal conductivity copper is 140 watts per. So this is fine. Then we can change more of these. So at this point, I'm just going to copy and paste it, add another one. So I'll save this time the material. We are using iron. Thermal conductivity is 70. Then we need our else statement. So else, we're just going to display this, that the material is unavailable. and then we need our end statement. So that is simply that for building this. I have the same thing here, so I'm just going to run something similar in this case, or rather, I'll probably just copy this and replace that so that we have the code we built. So now when we run this, still should have the thermal conductivity of steel. Well, let's separate this so that we don't get the material steel. So that should give us the thermal conductivity of steel. We produce in copper. And if we were to enter something else that was not there, tin maybe, should get material unavailable. So if that is how to use if to do that. Now to use switch, so I'll just get rid of this. So we switch material, and then case. So the first instance, we have steel. And then what should be run afterwards? That's the instruction. What should be done afterwards? So this should be the thermal right, so that should be in case it matches, and then the next case, and then on and on. So we have that out for all scenarios. Then we need otherwise. What should happen? Display material. That should be a character vector material unavailable. And then end. So this should achieve the same. So once I have that entered, I'm just going to copy. But before that, let's correct this. Make sure we have a string. Input allow strings. I'm going to paste that in this file I have here. And then you can run. And now the name of the material in lowercase, so maybe steel. And that should give us the thermal conductivity of steel. Copper. And then if we enter any other thing, like tin, you should get the same result. So this is how to use both conditional statements to deal with this particular problem. And then it's a matter of choice. The switch, when you have specific cases like this where you have a few instances of discrete variables, the switch is cleaner, but the if can also be used. So there's another example that gets the day, the numerical value of the day, and then gives you the equivalent name of the day. You could try that out. Now let's look at nested conditionals. So we can nest some of these statements. So a good example is if you had to choose a variable. So for instance, in our previous example, we were dealing with a system that asked us to choose the particular material, and then it returned the thermal conductivity of the material. Now, there could be a case where, because we know that matter exists in different states, the state could have an influence on the value of thermal conductivity. So you might want them to first specify the state. So even if it's ion, is it molten, is it liquid ion, or solid, is this, right? You can let them specify the state. It's also possible you have different materials that normally exist in different states. So you have gases, you have a model that can compute the thermal conductivity of different substances in different states. So you might first want them to choose a state and then choose a material applicable. So in that case, you need to nest your conditions where if they choose a particular state, then they are moved on to the next, and both of those choices are used to determine what the program should do. Right. So let's take a look at that. So that's what nested conditionals are. It's just having statements within statements, and it allows you to have secondary conditions after one condition has already been passed. So normally you can have 2, 3, 4 levels of nesting. It should work. However, usually if you factor your problem very well, you use the right operators and returns, you should not have to nest so many, because it gets to a point where it becomes very cumbersome. So as we go on, we'll see how to deal with that. So this is an example that takes the sensor value calibrated and asks whether it's calibrated or not. So if it's calibrated, then the first loop just checks if it's calibrated. If it's calibrated, if that's true, then it evaluates if the sensor value is greater than 100 and displays accordingly. Else, if it's greater than 50, it displays this, and then if it is greater than, or if it's anything else, it displays reading normal. So one thing to this is a tricky way to write the code. This only works because of the positioning of these two. So it's not the safest way to write a loop, a conditional statement, because if you passed a value of 150, both of these are satisfied, right? 150 satisfies, is greater than 50, is greater than 100. So the only reason why you will get the right reading in this case is because the first one comes before, and that's generally not a safe way to handle these. So you'd want to use the appropriate range or logical statements to enforce a clean range. So if we visit our previous example, we had a requirement that the user should specify the material. Now we are going to include the specification of the state. So the program will first check if the state is solid. If not, it will skip to the end of the state selection. And then if the state is solid, then it will then ask for the it will then execute the inner block. Right. So let's take a look at that. Let's first try to modify our switch to include that. So first we need another statement that asks for the state. Maybe that should come first. So state equals input, then we have enter the state of your material in lowercase. Should also be a string. And then let's terminate that. So now this should ask for both state and material, one after the other. And now we include an outer loop since, so let's use an if statement first. We can also use a switch. So if state is solid, and that is what we need to enter the loop. So once this is true, it will enter the switch and carry this out. And then we should have our end statement. So that's what this if is asking for. It should just have an end statement, and this is fine. All right, so let's also include an else for the if. Else let's have a display. Let's say no data available for this state. And so this end, let's position this appropriately. So the first end terminates the switch, right? So it should be, the whole switch statement should be sandwiched between the if. So this is like, if you look at this, this is your if statement with a condition, and then this whole thing becomes the action, right? The whole switch becomes the action, and then this is else, what it should do if this condition is not met, and then the end. Right, so this would give us that. So we can run this. So this is nesting a switch statement inside an if statement. And if I run that, it asks for the state of the material. I say solid, and then it asks for the material in lowercase. So I say steel, and then it gives me the thermal conductivity of steel. Let's try something else. Let's enter the name in the name of the state. So let's say gas. Ask for the material. Let's say steel. Then it says no data available because once we enter gas and this is not obeyed, it just jumps to the else statement and skips all of this in there. So that is really how to nest. It's a very straightforward thing, and we could have done so many things. We could have nested if in switch. So I'm just going to demonstrate some of that. So we could have nested a switch in a switch. In this example, we have the state, and we take the material, and then we switch the state. So if it's a solid, then it enters the next switch, which is the inner block, the inner switch. Now, if it's not solid, it just displays this. So we can equally run this. And then if we specify gas, and then steel, so it just says the thermal conductivity for the state is unavailable. Now we could do that with an if in an if. So if nested in an if statement. So here we still take the material and everything, and then if the state is solid, around the inner block. So this is the inner block that we've been using all along. And if it's not solid, then else thermal conductivity. You can have an if nested in a switch like this. Right, and again, this is the inner if block switch. Otherwise, display this. So if we run this, we say liquid. You get the material, we say copper, and because we didn't specify a solid, it just tells us that it's unavailable. But if we went solid and then went copper, we get the thermal conductivity of copper in there. You could also have a switch inside an if. And so you can nest them in any order. You just have to respect the rules of the conditional statements and get the syntax right, and it should work out. We can, maybe the better way to do this would be to ask for the state and only ask for any other prompt if the state is right. So we can just move this line. We just need to move this line. So in this case, it asks for the state, switches the state. If it's solid, then it should ask for the name of the material. Right, so in this case, we will only get the prompt to enter the name of the material if the state is right. So we can run this. Let's run this and see what happens. So we have entered the state. We say gas straight ahead. We get to know the thermal conductivity is unavailable for the state, and without being asked to enter the material. So this would be the best way to actually do it. Now if we enter solid, then the name of the material, copper, and then we get the name copper. So we only get to enter the name of the material if the right state is entered. So we can do that for the other examples subsequently. And so that is the way to write this program that computes the thermal conductivity of given materials. So that brings our lesson on conditional statements or conditional logic to an end. In our next lesson, we will look at a flow control and discuss loops in there. I'll see you in the next lesson.